Before, we talked a moment ago about the difference between whole language and phonics. And as you know, the reading wars have kind of shifted to the phonical side of the plate, so to speak, particularly in light of California's massive crash, having been on the edge of the whole language championing for a decade and saw a bunch of fourth graders crash and so forth. And so there is this move towards an integrated approach. And yet, it seems that apart from the distinction and processing frequency issues that we're talking about relative to oral language processing, that when we talk about reading, we're talking about something else, which is how all that works in relation to this code.
That's right.
This code is this man-made technology, and that a lot of our thinking, it appears, in terms of the whole language and phonics systems, are kind of compensations for the mess that's in that code. One of the things I'd like to draw out in our conversation now is the difference, as you would perceive it as a neuroscientist who's watching this, watching the timing and so forth, between the challenge to the brain of reading a phonetic code and reading a code that's not phonetic, or that has the degree of phonetic ambiguity that the English language does.
Right.
So it seems to me that, back to the timing precarious piece, that a phonetic code is much more straightforward from a processing point of view than a non-phonetic code in terms of the timing precarious challenges to the brain to work them out in sufficient time to sustain the stream flow.
Right.
So what I want to do is draw out from you how you could speak to that.
Okay. Different languages have more or less transparent orthographies. Okay. Orthography, of course, is the letter system. Now, it's interesting, in some languages, there's really a one-to-one relationship between the letter and the sound it makes. Spanish is one of those languages. There's a letter, there's a sound. And once you've learned those letters and those sounds, you can read just about any words that you want in Spanish, probably any words you want in Spanish correctly, even if you don't understand any of them. You can at least pronounce them correctly. And English is on the other end of the spectrum, it seems, with lots and lots of exceptions. I mean, who came up with E-N-O-U-G-H spells enough? It should be E-N-U-F. Okay. That would be fine. But so English has many, many exceptions. And that, of course, adds additional complexities. So what I've described in terms of this roadblock, as it were, in the use of the acoustic information, which is coming into the brain very quickly in time, and having to have that separated out and come up with nice, neat phoneme categories so that you can have those neurons that are firing together, wiring together, and getting really solidly wired. And that's going to work really well if you've got that all wired up for a system like Spanish. And it's going to work well for English, but it's not going to work perfectly for English because there's a whole lot of additional stuff that you have to pull in. So English is going to be a much more difficult language, and therefore we're going to probably have a lot more children struggling to learn it. Because there are additional brain processes. I mean, what happens is that there's always an interaction in the brain. There are very few, I mean, even though what we've learned in neuroscience, and we tend to think about in terms of this piece of the brain does X, and that piece of the brain does Y, and this other piece of the brain does Z, and we know that because if this piece gets broken, you know, because you got a hit on the head or you had a stroke or whatever, you tend to lose certain very discrete types of functions, and you can lose different functions. The reality is that if you look at these newer technologies that are able to image the brain in real time, not just take a picture of what lit up and subtract it out from everything else, but really follow using full head evoked potential or magnetoencephalography or something that can actually follow the response. In general, a lot of the brain is working to process information as complex as speech. And gosh, when you get into reading where you've got the language plus the written part of it to be decoded and reassembled and comprehended and whatever, we are really using a lot of parts of our brain. And we certainly can fractionate out certain subcomponents of the process. But the truth is that reading is one of the more complicated of the higher cognitive functions, using attention and rate of processing and sequencing and memory and the linguistic systems and the visual system, and it having to coordinate this dance that's going on. And the more complicated the translation from the orthography to the phonology is in a particular language, the more complicated this processing dance has to be within the brain. And so I think the search for a single cause, for example, or a single basis for reading in the brain, a single spot in the brain that's going to be activated for reading, or a single cause why a child may have difficulty learning to read, is both fruitless and not likely to ultimately be correct, because it's too much of a dance. As I said, it requires too many moving parts. And that's one of the reasons, of course, it's one of the most fascinating areas of neuroscience. It's sort of like the last frontier, as it were, I mean, other than consciousness. I mean, it's really high-level processing that involves many aspects. And if we can ultimately decode that, I mean, not decode it, but break it down, okay, we'll understand a great deal about how the brain works. And that's one of the reasons there's so much interest, in addition to just the human suffering that goes on for those individuals who are struggling with language and reading. Why is there so much interest in literacy, and why is there so? I mean, language really does take us everywhere. If we think about what makes us human and what makes us be able to function differently, ultimately, it is language, first oral language, and of course subsequently written language. But from the time we're born, our interaction with our parents, our interaction with peers, our interactions with our sense of self, very wrapped up with the language system. And so, again, to try to separate out language, let's say, from the sense of the development of self-esteem, the self-worth, and then, of course, you add into that a child who might be struggling at school. Although I've heard many parents say, you know, it's such a frustrating problem, dyslexia or language learning problems or whatever, because everyone looks at your child and thinks they're fine, you know. If they just worked a little harder, they would be just fine. And yet you can see a child literally who started off being fine begin to wither on the vine as they begin to struggle at school and lose so much of their self-esteem in the process. So this is a major problem. Not only is it a major problem for long-term economic development of the country, of course, which is why I think a huge focus on literacy, whatever is, and everything. Of course, all children have to read. But I think that it's also a huge problem as just for humans to recognize the tremendous toll failure in school, and usually that manifests itself earliest as failure in learning to read, has on the development and the maintenance of self-esteem. And the sense of the individuals who've had difficulty learning to talk or learning to read or learning to communicate. I mean, to the time they're adults, very successful, doing very, very well many times, they still, if you start to ask them about any of their earlier experiences, you can see that the pain of that failure or sense of failure has never left the person. So